Okay. Hi everyone, we're here again. If you're here, talk to me, tell me hi. I think it's working, although YouTube says no data. I really think it's streaming. Just let me know if you can hear me or you can see me, and I shall make a barrage of this, but I promised myself I'll do this every day, so I am gonna do it. Custom Zephyr application. So yesterday we went through and we opened a PR here, and my mouse doesn't want to work. This is not cool. This does not help. This does not help. So my mouse doesn't want to work. So that's good. So we opened this PR here where we went through the files and we basically did a bunch of additions. We added the kconfig option for the state machine, and then we built we added the framework of the state machine to our app. So now we have let me get the hardware. So now we have a state machine in our app, and it works. The state machine itself works, but then we need to I know what to do. Control Shift T. I like this one to be 2, and then I want to do that screen. I think I'll do USB SCM 0. Ooh, that's a very weird baud rate. 115200. I think that's the right one. Yeah, cool. So you see, you know what? I'll disconnect it. Let's point up. And then, oh, yeah. And I think we should see the, you know what? I'm going to disable some of the logs so that we can kind of get some good logs. The easiest way to do that would be to just not init stuff. So just take this out. Just take that out. And then probably things like that one and that one. And then that one and that one, and then that whole thing is commented out. And then let's quickly build this. Activate source. Control R source. Yes, let's activate the West environment. And then let's Control R, let's build, and then let's build for that. And then I just want one log so that we can see what is actually happening, and then we can kind of conceptualize where to go from there. Cool. Yeah. That's building. So what I actually want us to do today is to move towards an event-driven architecture using the state machine that we built. Which is, I mean, really, to be honest, the reason we were building the state machine in the first place was so that we can actually do an event-driven architecture and become really deterministic, so that we know what is happening in the app and what is happening in response to the thing happening in the app. Okay, and that makes it easier for you to do things like certification, safety, and such for apps. So let that build. While that's building, let's look at the code. Let's look at the code while that's building. So while that's building, we can come back and look at the code. So if you notice in our current app, we have an implicit state that's spread everywhere. Let's look at the temperature service and we'll see. So there's this, first of all, there's a message queue, and it's an extern. That kind of tells you it exists somewhere else, So there's a message queue for temperatures, and then if we look at our BLE service, I assume, yeah, we have an extern that you see now we have an extern here that uses the temperature message queue. Okay, cool. So because it wants to read from that, and this is spread between two translation units or modules, whatever what you want to call them. But then again, we have this really ugly thing here, which is the float, which is a global of the float, which is a temperature float. That's kind of not cool, because so basically our app is leaking data from modules to modules, and then you change. If I wanted to change this float or some character about this temperature, or maybe I move to some other thermometer and I get enums or something, or I get bits rather than a float, this would be difficult because I would have to go throughout the whole application and change it and out. You see, and what we want to do is we want to build something known as producer consumer sort of architecture. Would you call it an architecture? We looked it up. Producer consumer pattern. Yeah, pattern. Let's look at the producer consumer pattern. So what we want to do is want to build some sort of thing. Yeah. Oh my word, this is cool. It works out. I've never seen this. I've never been here. This picture is exactly the thing. So look at this. So there's producer threads, and basically you have threads that are making up data, you know. And then you have, on the other side, you have consumer threads that are consuming or using this this data that is being made up. And in our application, in the current application that we have, the temperature thread, you see in here, if I go to the top, we have a temp thread, a BLE thread, and an audio thread. The audio thread being the one we've worked on the most recent, but we're kind of pausing on it so that we can structure into event driven, and then we'll go back to the audio thread. But basically what is happening here is we have some things that make data and we have some things that consume data. So the temperature thread measures a sensor every 2 seconds. It measures a sensor, and then it takes the current measurement and it puts it in a certain queue. And then we have the BLE service or the BLE thread, which waits for a central device to consume something from it. So you see here, it waits for a central device to read. This is the log I always show when I read a temperature value from my phone. But basically, the BLE service uses the temperature data that the temperature service produces. But because of the way we've done it, because we're building up, like we're going from scratch, and this is design in progress, which is what engineering is. It's basically design in progress. Is what we have here is we have a global float that is updated by look at this thread. Look at this thread here. This is how you know we're doing something wrong. So in our BLE thread, the reason we keep running a periodic BLE thread is so that we can update the global temperature float in BLE. So there's a thread that we keep running just so it can watch something else. And we don't need anything else. If the BLE thread could just fetch the most recent float from somewhere, we wouldn't need to run this thread every 5 seconds or whatever. And as I said that, I kind of see a way where we can do it with just I guess you could, but first of all, we could just do this. Just read from the message queue straight. We could just do reading from the message queue straight in our read custom characteristic. and that would fix one thing. Yeah, but then there's this. Then what happens is, which is a way of developing, where what happens is you have this. There's parts of the application that are speaking to each other without some context of them speaking to each other somewhere else. It's a good thing, because then later, if we needed to split this into different completely apps, it might be okay. But it will be more robust, and it will be easier to add features to the application later, because right now it's already growing big, and it's becoming kind of cumbersome, because where do we put the audio sensing, and do we do audio sensing after temperature, do we do temperature after audio, and then where do we do the machine learning to check the keyword spotting for this thing? It's a little mixed up, you see. And this is just with 3 threads. Imagine if we had 20 threads and they're all doing something different, and they're all talking to each other in this custom ways. It would be, every time you wanted to add a feature to the application, it would be so hard, because you'd have to follow this data or into all of these places and such. And now that's where the event-driven thing, or the event-driven architecture, or the event-driven pattern, which is the producer-consumer pattern, comes into place. Yesterday we used this document from the Zephyr docs, this one, to basically construct this. What did we build? This is what we did yesterday. So this is what we made. No, this is hierarchical states. So we're on a flat state machine. There's some, just a moment. So SO, S1, S2. Yes, this is what we did yesterday. So this is the diff here. No, I want to keep that because we'll come for it later. Custom BLE service. And today might just end up being a thing where we reason through what we need to do, and we probably start doing it, and then we won't get to finishing it because I'm a little busy later. Okay, cool. So this is what we went through. We made some app states, and then we handled the app states. And the reason I was building the app, and the reason I went into this explanation, was because I was building the app, Control R, and then we want --HW. Yeah, cool. Let's pack it. And then Control R, we want DFU. Yeah, but I'm gonna put the app in DFU mode, or the board in DFU mode, and then I'm gonna push this in. Does that work? No. So another reason that doesn't work is because I put that there. Ah, I see. It's here. So I just pass that. Yes, is it like that? Yeah, cool. And basically, in this one, I'm not initializing anything else, so we should be able to see the state machine log, and we know that the state machine is working. Cool. And in here, let's do this. Something is crashing. Something is crashing. I don't know why. Something is crashing, and I don't know why. Gee. Why are you crashing? 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 Anyways, I'm just gonna put this back. I'm clearly very distracted today. What I wanted to show was that initial log, and I was not successful with that. I'm very distracted because I need to fix some other things, and this is kind of ancillary to that. Okay, if anyone has any questions so far, even though we've done that. Cool. Not yet so far. Let's build it. Let's build it. It'll come together. It will come together. So the reason I'm doing this is so that I can show you the logs. But essentially what we went through this yesterday and we built some states. We built all the states, run actions, entry actions, and exit actions for the states that we want. And since we have those, we now we initialize the state machine and it should log out what the state was. And that should be what I was trying to show now. Before we then use the help of Zephyr, and instead of doing this just a flat machine, we want to go lower in the document and introduce event-driven state machine example. And the thing, the reason we want to go event-driven is because it's how do I explain this? The reason we want to go event-driven is because it enables us to add features and adjust the application as we deem fit, as good as we want, as quickly as we want, fearlessly as well. You're not afraid of changing one thread because it will break other things, or because you have to follow down on everything that it breaks now. You can do that as it goes. That is basically what I'm saying. That's why we need to do event-driven. Yeah, cool. So let's pack this. Cool. And then after packing this, I'll put this thing in bootloader mode. And load it. And then I'm gonna go here, and then I'm gonna look at that light. And then a bit red, and then I want to start this. It's done. I want you to see entered idle. This is all I want to. Entered idle. So what does that mean? That our state is actually getting into idle. I think the other thing I can't do is probably, can I disable logs? Do I want to disable logs? I don't really want to disable logs, but I don't know why when I disable all the services it breaks. It's probably because all the threads are made above, and then it just fails because of that. That's okay for now. We'll get to that. So let's do something. Let's move all of this into its own thread so that we can reason about it by itself, see if it works, and then we come back to this. And then another thing we can do is, because we're not using them, for the next time that we are going to be here, I think it is here, and I think this is a thing I want to remove. I would print this because we know we have them, and then I think something like void unused. Can I unuse something? Can I void something? RMS float. Yeah. To avoid avoid logs, or rather to avoid unused error. Okay, cool. And then you see this log can go to the state machine instead of being here, so that we just don't need it right now. And then that's okay. And then I think the other one that we keep seeing is, which ones do we see? Let's look at them. Which ones do we see? There's this one. This one's take a lot of space. Audio model, yes. Reading temp normal. Reading temp normal. Reading temp normal. Yeah, we can also remove that one. Reading temp. Reading temp. Temp of queue. Queue. We can leave the full queue. Yeah. So that happens slowly. So let's remove the reading one. And then the thing that's going to happen now is we're going to be able to see, yeah, this one. I don't need this log anymore because we know it's coming. And then let's go into here. Let's build it again. But basically, I've shown what I needed to show, which is that we do actually invoke the state machine, so it is working. And what I want us to do now is actually start making a new thread. Let's make a new thread. While that's building, it'll. By the time we're done making the new thread, we should be able to come back and then. Okay, so let's make a new thread, and then we can go for it from there. So k thread define, and then yeah, FSM thread ID, FSM thread ID. I'll give it the same thread stack size, right? And then I will. Is this an entry point? FSM run thread. This is probably come from an input that I will get above. It's gonna be a there's gonna be, and then we'll put the priority to be quite higher than everything else, and then all of this can be just nulls for now. And then that's gonna make a problem because we need to make an FSM thread here. Include I think FSM service.h. This will now not build until we finish this. Okay. So in here, let's make an FSM service.h. FSM service.h. And then let's save that, and then PV, and then I wanna get a really simple one. Yeah. Simple one like that, and then I wanna do Y, and then PV, and then I wanna go FSM service, and then okay, so this is going to be FSM service, first of all. FSM service. I don't know if it's, I don't have enough time to learn how to do this. I don't know, we'll see. FSM service. And then I don't think I need this one. 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 I think all I need is void FSM. Wait, yeah, this one. I need void FSM run. Let's look at me. Which one do I need? FSM run thread. Void FSM run thread. FSM, and then here I can say run thread. So that should actually make something work. And then if I do in here, I can make an FSM service.c. And then here, all I need to do is I need to save this, and then I need to hash include. It's going to be FSM service.h. And then in here, what I need to do is void FSM. And then in here, all I need to do is to just go in here, all the way to the end. And then what I need to do here is something like low. It's fine, we should do that. and then I think I need to include Zephyr logging, include. Yeah, let's do this one before the local one. Need a space there. Include Zephyr logging log, and then I want to register a log module. Yeah, and then here I want to call it FSM module. I think that's it. That's all I want to do. And then yeah, is that okay? And then here I want to do log.warn FSM thread is running, and then all I want to do is do that, and then I want to do sleep k sleep k seconds, and then I want to do 5, so something like that. That should be good. And then this should make our main. This should make our main stop throwing errors. Yeah, so that is now not throwing errors, and I assume if we do run this, it's gonna actually work. It might actually work. So let's build this. Any questions so far? Well, that's building. Yeah, and I'll put my phone in silent as well. Okay, any questions so far? Any questions so far while the build is up? Hello, Batlomage. Hello. Hi. Thanks for hanging out with me while I'm working today. Is there anything I can explain better? Is there anything I can move through slower? Sometimes I rush through these things. Feel free to interrupt me with as many questions as you want. And the reason I look that way is because that's the screen with the YouTube thing. Cool. That's almost built. Yeah. Then let's pack this. Let us pack this. Pack it into a zip. Cool. And then let's put the board in bootloader mode. Hey, Bartholomew, if that's your name, where are you from? Put it in the chat if you're watching. Let me know where you're from. That'll be quite cool to know. Where are you from? Gonna flash that. Flash that. Oh yeah, so let me go here so that we can see it. Yeah, so FSM thread is running, entered idle, FSM thread is running. Wow, from Poland. Amazing. Welcome. That's cool. You're from Poland? And how did you know I was streaming? Where did you see the message that I was streaming? Do you follow me from YouTube? Who else is here? I can see all the people online. I can see the concurrent viewers. Please do chat up and say where you're from. So basically what I'm saying, what I'm trying to show here is that the FSM thread is running and it's working. Nice to meet you. Thank you so much for coming, Bartholomew, and I'll try and make it worth it for you. So cool. So that's it. The FSM thread is actually running. So that works. So let us move all the work that we did yesterday into the FSM thread. And then actually think about how to do this. Because now, once this is in a thread, we'll see how we make it work. But let's move everything we did yesterday into a thread. X. It's always scary. And then let's go into the FSM service, and then before this, we shall put SP. And then that's that. I know what we need now, and then we need to go to main and get everything that we added for the state out. SMF. And then FSM service. I should probably start moving these things into their own folders, but not yet. If I do it too quickly, then the app looks too big too quickly, and then that's not cool. And then I think in main I can now do this. I can grab this one and X, and then boom, boom. And then what I can't do is go like main. And I can go into the main service, and then I can go in here, and I can do something like thank you, Bartlemy. Cheers, man. Oh, are you looking for the? If you're setting it to 1 week back and you timed Zephyr, are you looking for the videos from the recent Zephyr meetup that happened in, where was it? Was it in Germany or France just now? Is that what you're looking for? They're going to be on the Linux Foundation channel. While one is that. And then there's that. And then I'll do that. I'll put that in here, and then I'll do SP. Yeah. So what does this do? This does an entry point, and the first time if you notice, we did do case sleep 5 seconds, but I'll show you something. Oh, I did do a low power thing the other day, and I can do a better one, another one, but low power is quite like accessible. Let me finish my train of thought here, and then I'll show it while this builds. So if you notice, our logs don't show periodic idle. I mean a periodic FSM thread running. So now let's fix that so that it can do that. And then while it's building, we'll answer Bartholomew's question, I think. Bartholomew, so I'm pretty sure you've seen it, but yeah, I can use this. I don't need that. Zephyr, what is it? Zephyr power management. I'm pretty sure you've seen it, but so if you want to do power management with Zephyr, this is a really good resource, and then you can do it a few different ways. You can either do it as I believe you can do it as device runtime, or you can do it as system power management, but the device runtime is preferred. Where you actually the device drivers and they register these callbacks where they can be in a power state or not, and yeah. But we've done another bit previously. If you want me to do a focused power management sample or something, let me know. Yeah, from Open Source Summit. Yes, those videos are going to be in the Linux Foundation channel. I don't know if they're on. I'm also waiting for them. Yes, perfect. Let's see if it's building. Yeah, it built. It built. It built. So after it builds, let's pack it into some place. Okay, cool. And then after that, let's go and let me put the board in bootloader mode. And then this is going to be, I'm just going to send the thing onto it. And then this will be disconnected, yes. Send the thing up. And what we should get now is an FSM thread that is periodically running, basically. Yes, FSM entered idle. Yes, exactly, FSM thread is running. And if you give it 5 seconds, I'm originally from Kenya, but I live in South Africa now. These lectures are not really for students, but students can use them. I usually stream 9 a.m. SAST or Central European Time, 9:30 a.m., 9:30 in the morning, Central European Time, and I try and stream every day. I don't think these lectures are for students. I think you can use these lectures if you do professional stuff, because really, if you guys want the truth, these lectures are just me doing research for the projects that I'm doing at work. I like doing it this way. I wish that I could see some of the people who taught me the things I'm doing. I wish I could see them work. So the reason I do these lectures is so that other people who want to see someone working through a real problem can watch. Yes, I stream on weekends too. The weekend streams are a bit longer. They're a bit longer, and sometimes I might tackle something that is not in Zephyr. It could be machine learning, or it could be something else, or something I'm interested in. Right now, my weekends are quite focused on building neural networks. And I'm not building the next greatest one. I'm just building one so that I can see how it works, because at work I have to do work with neural networks, and I'm building my intuition for that. And also, I really like computers and how they work. So yeah, that's why I do these streams, so that I can share knowledge, I can get asked questions, and I can answer questions, something of the sort. Cool. Thank you, Bartolomeo. I like that. So, I hope I'm saying your name right, or even close to right, man. So here's the thing. So what do we see here? We see every 5 seconds we're getting FSM thread is running, and we have a sensor module that is running in the background. We should probably call it a temperature module. Temperature module, you know, that would separate it really nicely, I think. And yeah, try not to like jump into temperature module. Okay. Yes. Stream starts at 9:30 Central European Time. Yes. Yes. That's my time zone. CET time. 10:13. It is 10:13 here as well. Yes, 9:30 Central European Time. I'm streaming. Perfect. So cool. And usually I'll share some notes after. Thank you. No worries. Thank you for chatting with me. Cool. So we now have, we've renamed this to the temperature module. I've just renamed that so that this says temperature module. It's more specific rather than sensor module, because we might add sensors later. And then let's look at something else. So let's now actually go back to the Zephyr documentation and go and see how to sort of build a state machine, because now at the moment what we have is a very pretty we have a very pretty state machine, but it doesn't do much. It just tells us the state machine thread is running, and there's not really much happening there. We have defined our states. We have defined our we have defined our states. We have defined our run, entry, and exit functions for the states themselves. But right now, what we need to do is start to transition between states. Okay? And the only thing we do right now is we jump into the initial state, which is idle. So let's go and look at some documentation and what we need to do so that we can start actually making this thing work for us. And possibly if we can find a way of removing that global that we're passing around, that global of the temperature float, and perhaps we can use the state machine to do that. So let's go look at Zephyr documentation and see if we can do that. And I'm gonna do a control ++ so that people can see. So let's look at this event-driven state machine example, which is why we want to do this. So we can list some events, cool, and then this one is based on GPIO. So, but ours is not GPIO. So let's look at it. We can list some events, and then based on those events, we can add those events into our state object, which we have already. Okay, so we can add the events here. It's basically it's a 32-bit integer. It's one integer that can basically store many events. It becomes a mask if you do it like this, because then the bit function left shifts however many you say. So here it says left shift one into the least significant bit of an event. Okay, so this is going to be a list of events. Below, let's go and make a few events, and then we can see in our app. So we have connected. We have temperature is ready, probably temperature read, mic capture. So let's list some events at the top before we get into it. So list of events, list of app events. I'm just human. I get nervous, especially when I'm trying to make new friends. And list of app of events. Okay, cool. So in here, let's make a connected event. Define event. This is actually not the one I want, to be honest, because connected implies something different. Connected implies that someone has actually joined the peer network, or rather the peripheral network. But we can add some callbacks to actually make it a connected event. Central connected. Okay, so and then we'll do bit 0. Okay, and then we'll do define event temp red, and then we can do this one to bit 1, yeah, and then we can do define audio event audio detected, and then we can do bit 2, and then you can do define error, event error occurred, bit. Ah, my cat's complaining. Okay, cool. So what have we done here? It's quite easy to see what this does if you know of the Zephyr utility function. Yeah, here it is. It shifts the one unsigned into whatever number you pass it into a 32-bit thing. So you can have, what we're doing here is we're building a bit mask for checking which event happened later, if that's making any sense. Cool. I'm busy now. Yes, Jan is very busy on me. Cool. So we're building a bit mask of all the events that could occur. That's what's happening here. So in our states, we have an idle state, we have a connected state, we have a temp read state, temp read or read state. I feel like this one should be temp ready. Temp ready state. What platform and okay, cool. So right now I'm building on an NRF 52840, and what I have is an I2S mic on the just connected next to the thing. It's very rudimentary. It's nothing special. And then I'm faking a temperature sensor by using the die temp in the NRF 52840 has a die temp in it, and I'm using that to I'm reading temperatures for that. Yeah, a BLE dongle. Yeah, basically. Yeah, perfect. You know what you're doing. You know what you're saying. So you understand really quickly. Okay, cool. So I made that. So we listed the events that could occur in our application. Now, let's go back to the example and see how that works. So this is just set up for them. We don't need to do that setup. We've done list of states. We've done that. List of events. K event and SMF event. Let's do this. Let's add event and events to our state object. So here's our state object. Remember, this must be fast form casting, because this is always casted. So, and then let's put some space there so people always rest of the state stuff. Okay, cool. So let's add that. I think it was SMF event, if I'm not wrong. SMF event, K event. Is it K event? It's a K event. It's a Zephyr event. Struct K event, SMF event, and then sorry about that. And then after it, we'll add an int 32. I don't know if this should be time, but it's fine. Event. What we've just done there is we've defined two things. The int 32 is a 32-bit integer that contains a mask of all the events that could occur. So there's all these markers where an event could occur. And then the K event is this is an event. It's an event primitive from Zephyr that helps us deal with this kind of situation. And this is the sort of reason I like Zephyr, because you get like, initially I had planned on building my own events. And then once I had built my own events, I would once I built my own events, then I would use them. But then the more I looked into the code, I realized Zephyr has this K event primitive that I can use. So that's cool. And also, it's cool that they show you a state machine example, and then further they show you an event-driven architecture on a state machine, because then you're able to do all of these things with the stuff. Okay, cool. So we've built a state object. We have all of this entries and runs. Let's think about this. So in our runs, we can now use the event that occurred. Oh wow, this is so cool. So what this enables us to do is that whenever we are in a certain state, we will know what, whenever we're in a certain state and we get called in our run, we will know what event occurred, and based on the state that we are in, we can respond accordingly. We can even implement some sort of button-led thing. I can see how this can become a button-led thing. It's cool to use a button-led thing, because then you can use one button, but it can you can use one button to toggle a LED. Usually think about it this way. You can use one button to toggle a LED. So what am I saying? Usually you have a button. If you're using it that way and you're toggling a LED with a button, what you're doing is when you press the button, the LED goes on. When you press the button, the LED goes off. But with a state machine, every press can mean something different, because we know the state we're coming from. So in that example, you can have one button, and if you press it, the LED goes on and stays on. The next time you press it, because you are in an on state, the LED goes off and stays off. That's basically what is happening. Whenever we come into a state, we know let's do an example. Let's do a quick example. Let's take this. Let's see how they do it. So inside the event, you check the event. You do a mask. You check the events, which is the 32-bit, and then you AND it with the event button. And then if this is true, then we are in that state, and then you can depending on the state you're in, you can handle as many other transition states as possible. Basically, is what I'm saying. Let's quickly do an example. I don't have that much time left for today's stream, but I think I can finish an example with this one, and it would be quite a complete run through. So let's go into the idle one. Instead of setting the state into idle. No, I'm confused. So there should be an additional step somewhere else. Yeah, cool. Initialize the event, SMF event, SObject event, cool. That's just a struct. And then set the initial state, cool. And then now block on events. Block on events. I don't really want to block on events because I don't want to hold the execution context. Let's do it. Let's just do it until it doesn't work. So let's think about when we get into idle. Let's see how they do state 0. So when you get into an event, you check whether there is a button press. and then you set that state. You set S1, S0. From S1 you set S0. From S0 you set S1. I can still do that. Let's check it that when you get into idle, we jump you to connected. But we still don't have an event. We're still not firing an event. Where are we firing events? How do we fire events? Probably in some callback somewhere. Button press, k event post, button press. So just get into idle and you post an event. In idle, post an event. Can we post an event from idle? Let's do that. K event post SMF object, state object, SMF event button press. So in idle, before I set the state here, let's use the state machine now. In idle, what I want to happen in idle is no, don't post it here. They're transitioning states from a different state. So that's actually an implementation detail. The way they're doing it is an implementation detail. I'm starting to understand how it works. The way they're doing it is an implementation detail. So they're going from, if you press a button in this state, go to that state. If you press a button in that state, go to this state. Maybe that's not what we want, because that's not how our transition works. But what we can do is, let's think about in idle. We can put it in idle. Yeah. We can put it in idle here, down here. We can go into idle, and then we can do a k-sleep. Seconds, and then something like 2. Cool. And then I still need to finish all the setup. So let's do the setup first. So initialize the event and set the initial state. Initialize the event. So let's first initialize the event here. K event init. And then here it takes what? This object and this object state event, SMF event. Just a moment. I need to decide whether that's a name or it's a K event, so SMF event, so that's fine. State object. Okay, cool. So initialize that and take the state object dot SMF event, and then in there we want to, what is it? That's it. So initialize events, and then that's cool. Initialize the event, cool, and then set the initial state. Wait for 2 seconds. Do this. K post event, isn't it? I want this. K event post. Okay, that's why it doesn't work. K event post, and then what do I want? The object first, and SMF, and state object. And state object, and then dot SMF event, and then in here what I want to post is some sort of event connected. Let's just go connected, central connected. It doesn't do anything right now, so just leave it at that. It's an example. We want the state machine to do state machine work. and then we can start breaking down our own application and making it state machinable. And then all of this code will be up on the pull request. If I'm looking at you, Bartholomew, if anyone wants to go and add stuff to it, just do it. Just do it. Add a pull request onto my pull request, edit my pull request. I don't care. It's cool. We are all trying to research together. So we wait for that event to be posted. And then, do I want to block? Do I really want to block? I don't think I want to block. K-event wait. Let me look at K-event wait. I can wait for 2 milliseconds or something. Okay. So that's cool. So let's go into while one. Let's remove this. Let's remove this useless wait. And then in here, instead of even actually latching onto a wait, let's actually latch onto K-event wait. K-event wait. So what I wonder if we can use a message queue, because my head is having problems with how to hold this and not block all the other things in my application. So I wonder if I can react to some sort of message queue here, and that the rest of my application can post through that message queue, and then here I can just wait on that message queue. But let's just make it work the way it is right now. And S state object, and then SMF event, and then that is just wait on. I want to see K event wait. I want to see how that works before I go on. K event wait. Wait for any of the specified events. Set of desired event to wait on. So is that going to be some sort of list? Can I pass a list here? Can I pass enum? Can I pass an enum there? Poof! Come on. Why am I looking? Oh yeah. Can I pass an enum there? It's not a pointer. Anyways, let's just wait for the one we will post. So let's wait for event connected. And then let's wait for that. And then I think I want to bool reset. What does reset do? No, I won't. I'll leave it off. Do they clear it? True. No, that's fine. Let's do it. True. And then do something like k msec, something like 10. That's fine for now. And then if I do get an event, what do I do? So this is K event. Is it? S. Oh, we're setting it. Okay. Okay, I see now. State object. Is it and? It's probably and. It's state object dot equals that. Yeah, I see. Yeah, I see. But it's not a new line, should I do? Okay. And then what do we do here? Okay, so we actually manipulate the state object itself, and then we set a state. But because we set a state, excuse me. Watch it. We set a state. We set a state in the object, and then what we do is we run the set state by just passing the run the object itself, the state object, into run state. Okay, cool. So let's do return ret is equal to, this is quite messy for now. I will do actually int ret equals, because we don't know if this will work and we want to get an error if that. SMF run event run state, and then here we want to do the SMF CTX, and then that's that. And then what we want to do is add state object, and then that's it. And then the other, that's actually two of them, I think. If ret equals 0, log the error state machine exploded, and then let's do here excuse me, just a moment. And then what do you do? And then basically, do you want to sleep or do you want to just keep going? Yeah, cool. I will break, because if it's broken, then let's just break that. Break. And then let's do another thing. So let's do something. Let's go to connected. We want to run connected. Connected run. We will say left idle connected run. Connected doesn't even have an entry. That's cool. So let's do log one, something like connected state is being run. Okay. It's okay. The rest of the app might even crash, because that's a blocking call that's on the state machine. But this is something we fix with something like a queue, and then you're basically, from your threads, you're bubbling up into a queue, and then you're also boiling down. Cool. Let's see if that even builds. I really will have to stop now, because I have a meeting in 15 minutes that I have to go to, and I have to go to a meeting in 15 minutes, and I need to get ready for my meeting. And let's see if this builds, and if it transitions state. If it does build and transition states, we've won. We basically learned how to thread. We made a state machine yesterday. We've pulled it out into its own thread. We've now started dealing with events. Okay. The vanilla Zephyr. I'll do. I'll do a West version or something at the bottom. But I'm running completely vanilla Zephyr, and I believe it should say somewhere here. I'm running 4.2.9.9. The latest one, the latest version of Zephyr. Yeah, and sometimes I'm on a branch because sometimes I'm actually putting stuff into Zephyr itself. Yeah, and the code, but Numio, the code is on. Here's the code. I will share the code here. So yeah, I've shared a link of the code there, so you can go and run it by yourself and such. So it's built. Let's packet. Okay, cool. It's packed. I'm gonna put this thing into bootloader mode, and then I'll bomb into it, and then let's see. Need it to flash. I think it will crash. I don't even think it will log anything. I think it will crash. It is doing the thing. It is doing the thing. It is doing the thing. Cool. I'm gonna stop. But basically, if you can look at the screen now, it is working. We're transitioning state. It's in an endless loop by itself. And this is exactly what I was scared of. What we've done is we've made a state machine that consumes all the computing power and just eats up all the time. It doesn't ever wait. It doesn't ever yield for. It does look like it's yielding. It looks like oh yeah, it is yielding. I can see the temperature log running as well. It is yielding. So the state machine works in its own thread by itself because I can see the thread. I can see the temperature one yielding. So basically, what happens now is this is working. The state machine is working. Now what we need to do is go through our application slowly, bit by bit, look at which thread needs to be changed, which thread needs to go where, which thread needs to post what. We might need to add another message queue. Some globals will disappear. And what we have here is you have an application that's living by itself and that knows how to associate its own thing to itself. And when you start adding lots of features, lots of tasks, lots of all of these things, you're going to be able to add them so quickly and so fearlessly because you have a central connection of your application. So you can make stuff. You can make a thread and let it do its own thing, and then it just posts events up to the FSM, and the FSM handles the transitions to other things and such. Let me commit this so we can stop there. Oh, thank you so much. That was so cool. Control 8K. Sorry. Yeah, I'm gonna. Yeah. Actually, I'm lucky. I stopped it at a very nice place. See, it is yielding to the temperature thread. So all the other threads are running. Yes, the FSM thread is running as much as possible, which is what you want, and it should ideally sleep. I would make it sleep. Make it sleep so that. I would latch it onto a message queue. I would make it watch a message queue and not run unless a message queue is posted to. That's what I would do. And if you want to add a pull request that does that, Control A, K, Control A, K. Yes. Yes. And then let's actually just commit this stuff. Git status. Git add on src fsm. Yep. Git add main src main. Commit -v. Let's say. FSM work, and then what did we do? pulled out an FSM thread, and then moved FSM to FSM, moved FSM work to FSM thread. Status diff. Okay, git add src. Git status. Git add src. Git commit --m. Rename module, log module, and remove noisy logs. Git push. So that's up. State machine is working in its own thread by its own self. Now we need to hook up all our other threads into the state machine. Unfortunately, it's 10 minutes to my thing. I have to leave. Thank you so much for everyone that joined. Thank you so much for everyone that keeps joining. Thank you so much, Bartolomeo, for all the questions that you've asked and hanging out with me today and subscribing to my channel. Thank you. Cheers, everyone. See you tomorrow. We'll do something interesting again. Bye.